Hello, everyone. Thanks for coming back and joining us again. Sorry about last week. We had some technical difficulties, but hopefully things will run smoothly today. My name is Matt Yonkovit, and our webinar here is about switching to Innodb from MYISAM. Just wanted to say we appreciate everyone coming out here. So, wanted to start with a little bit about who we are, who I am, and who Percona is. I am Matt Yonkovit. I'm a principal architect here at Percona. I've actually worked for MySQL, Sun, Percona, as well as several other companies, Fortune 500, little mom and pop shops, kind of done it all. Done more than just MySQL, I've done Oracle, SQL Server, DB2, kind of run the whole gamut. Percona is a company that's made up of quite a few guys just like me who have done a large amount of work in the database industry, specifically around MySQL, but we've done other things as well. And we offer support, consulting, training, and even custom development. You may have heard of Xtradb and Xtradb. Those are two of the products that we have built and support. In fact, tomorrow there's a webinar on Xtradb. Before I get too much further, wanted to let you know we're going to try and take some questions at the end. I'm not going to stop in the middle of the presentation. Don't want to stop. Just want to kind of flow through it. We'll take a few minutes, if time permits, to answer any questions. If you want to go ahead and send them out to either everyone or all the panelists, hopefully we'll be able to get some answers to those. And if not, we can always chat via email or via our Google discussion group if you have other questions. So just wanted to throw that out there. So, hold on a second. So what do we do as a company, Percona? Obviously, we offer consulting services, and it's not just around your standard database consulting services. We do more than just, hey, fix this, fix that, adjust this. We offer architecture and design around, database systems, around, larger web scale systems. We offer performance tuning. We help you build high availability systems. We build custom builds for clients who have specific problems or hit specific inefficiencies in MySQL. And we also do, of course, the troubleshooting, which kind of leads us into support, which we just released a new support offering. We also do training, we do development, and of course we do benchmarking for several large companies. Who we do it for. This is just a few of the clients who we've worked with and we've helped. So, there's many, many more, and they wouldn't actually fit on one, sheet. But, these are just a few that we've worked with recently that we thought we would put out here to show you that, hey, we're not just some fly-by-the-night, company. We actually have, some really large clients that are really happy with our work. So now let's get into more of the technical content here. Obviously, the goal of our presentation here is to, walk through, some of the things that happen or that you have to watch out for during a migration from MyISAM to Innodb. However, I wanted to throw some disclaimers. This isn't a presentation on Innodb or Xtradb. While we will talk about these technologies a little bit, you're better listening to either the webinar tomorrow or finding supplemental materials elsewhere on the web in order to find, details specific on Innodb. I just don't have enough time to go do a deep dive into Innodb. I also am going to make the assumption that you have used MySQL and you are aware of it. This isn't a low-level type of a webinar. This isn't an introduction. This assumes that things like, what is a storage engine, and, you've actually used MySQL in production or elsewhere. So let's start with a little bit about the history of things. Specifically, let's talk about MyISAM. Okay, MyISAM is kind of the granddaddy of all of the storage engines. It's been around a long time. You know, a lot of applications were built around MyISAM and have optimization specifically for MyISAM. You know, it's a very simple storage engine without a lot of complex moving parts, which appealed to a lot of people. But it's kind of a double-edged sword there. You know, in some cases, complexity can be bad, but in other times, it can be good. So we'll talk a little bit more about, you know, some of the features that had to be omitted to make MyISAM, you know, the simple storage engine that it is today. Conversely, or also, because it's a lot simpler, there's not a lot of tweaks in performance optimizations you can do with MyISAM, certainly not to the level that there is with like an Innodb. So, you know, it's simple, it works, you know, people could throw it out there for their blog or their website for years and years, and, you know, it just worked great. And then as things started to get bigger and bigger, then you had to think outside the box a little bit more. One of the things that MyISAM does have is built-in support for full text indexes, which is a huge feature that we still see a lot of people take advantage of. And also, you know, it does a really good job of compressing data. Okay. So some of the things that, you know, that had to be overlooked or kind of pushed off to the side to promote, you know, the simplicity of things and, you know, to make it, you know, performant and fast and completed, you know, cause some issues. So for instance, you know, MyISAM does, you know, table level locking. You know, it's not crash safe. You know, so, you know, if your system crashes, you are going to lose data. Okay, so that's, you know, one thing that, you know, a lot of people, you know, have issues with. I have issues with losing data as well. One of the other things is only index pages are in the key buffer. So if you're familiar with MyISAM, you've probably tweaked the key buffer size. The key buffer size is one of the main tweaks that you can do in MyISAM. That basically allocates more memory to MySQL or MyISAM specifically in order to buffer the indexes. Well, you can only do indexes. So non-indexed columns and have to be read directly from disk or from the file system cache. So that can actually be fairly slow. There's a certain level of maintenance that has to occur regularly. So you have to run things like optimize and analyze and check and things. So if you're running MyISAM right now, you probably have a lot of those sort of maintenance jobs built and running. I mentioned earlier that there's limited options for instrumentation and tweaking. That, you know, that's something that when you get to a very large scale website or even you know, a fairly moderate size, some of the instrumentation and the ability to tweak things can really come back and bite you. So that's one of the things that we've heard as a significant issue for a lot of clients. And also right now there's really limited development going on within MariaDB or MyISAM. Specifically, you know, there is some work going on around Maria or ARIA, which is was going to be the replacement for MyISAM, but the main line or the stock MyISAM isn't getting a lot of love right now. So you know, it's something that it might not seem like an issue, but you know, as other storage engines advance, MyISAM just kind of seems to stay a little stagnant. So you know, because of those issues, and because people also wanted a transactional storage engine, Innodb was introduced into MySQL. As a storage engine, it's a drop-in replacement, so you know it should work, you know, with all the SQL that you have running against MyISAM, so you won't have to make any changes. You know, it's ACID compliant, so you know that this is kind of one of the big, you know, features that people looked to Innodb in the early days for was, hey, you know, I can have transactional support. I don't have table locking. And it was added in the later versions of 3.2. It's in the Max builds and then in the mainline 4 builds. Initially, so some of the key features here that Innodb offered over MYISAM was the row-level locking, the crash recovery, but it also offered the ability to have both the data pages and indexes stored in memory as opposed to just the indexes. Okay, so that was a huge thing. Foreign key support as well. That was a fairly big feature that was added that a lot of people take advantage of. And a lot of the automated maintenance tasks that I mentioned, analyze and optimize and things, those don't need to happen in Innodb. So things like analyzing for statistics, Innodb generates its own statistics behind the scenes, which is actually a double-edged sword as well. It's good and bad. Okay, so Innodb, having been built, kind of way back, it was actually built in '95. A lot of the code was optimized for machines with limited horsepower. It might have been a single, core machine, or it could be a machine with limited disk I/O capacity. In fact, there's actually comments in some of the code that say, "Oh, we're going to limit this to 100 disk I/Os," and it makes reference to that being the limit of current hardware. So, these types of limitations, as the hardware got better throughout the late '90s and into the early to mid 2000s, Innodb started to run into some issues with larger amounts of hardware. In fact, one of the things that we always ran into when I was working for MySQL a few years ago was the number of CPUs on boxes or the number of cores. We always saw these giant whether it was 16-core or 32-core type machines that people would try and throw MySQL on, and you actually got a performance regression after you hit a certain number of cores. So in this case, and this was a, I think this was like a 5060 type of a build here, I think, or 5068 or something. You'll actually see when you hit like 8 cores, the number of transactions actually starts to degrade. So you actually get less transactional throughput by giving more cores. And this was due to a lot of internal locking issues, whether it was mutex locks, semaphores. I mean, there was a whole slew of things that didn't allow MySQL to scale well on larger commodity hardware. So the thing with MySQL that really kind of propelled it, especially, or Innodb that really kind of propelled it, was the community response. Google started looking at this along about the same time Percona did, and started looking at, hey, Google's having problems, Percona's customers are having problems with Innodb and the scalability limits. What can we do to fix them? So, you might have heard of the Google patches. The Google patches were one of the early, first attempts at fixing many of these issues, and they did a wonderful job at, correcting many of the Innodb inefficiencies. The Percona patches and Percona as a whole has done, a great deal of work in this area as well. So, we're slowly pushing that curve that you saw with the 8 cores. It was going to 12, then it was going to 16, and now, we're responding much better on systems with up to like about 24 cores. And we keep on leapfrogging that, so that number might even be a little off now. But Oracle recognized, hey, this is something that, is an issue as well. So they actually released the Innodb plugin, which has a lot of features that, or similar features or concepts that were introduced in the Google patches and the Percona patches. So, the Innodb plugin came along and said, hey, we can, fix some of these issues that customers are seeing. And so that's been released. And we also took a lot of the Percona patches and the Innodb plugin, and we merged them together and continue to make fixes in Xtradb. So, there was a huge community effort, and there still is a huge community effort to fix a lot of these issues. So over probably the last, I want to say 3 years, 4 years, the majority of work around MySQL has been around Innodb and really pushing the the performance envelope. In fact, if you look at like the Innodb plugin, I believe the last time I looked, there were about 10 releases since 2008, so they're a fairly steady release cycle. And it makes sense because they're putting so much effort and it's become so stable in recent years that it become the default storage engine going forward. So as of 5.5, Innodb is scheduled to become the default storage engine in MySQL. Now, before anybody gets all worried, it doesn't mean that MyISAM is going away necessarily. MyISAM will still be there. If you have tables in MyISAM, if you upgrade to 5.5, they should still work, but check the README just in case. There's always little gotchas. It just means that any new tables that you create without the engine equals as part of the table creation will end up being created as Innodb as opposed to MyISAM. So, if you're not really paying attention, you could mix MyISAM and Innodb tables on the same system. Doesn't necessarily mean it's a bad thing, but it's something that you probably want to watch out for. In fact, the mixing of storage engines is a problem that we run into quite frequently. A lot of shops already assume that they're 100% MyISAM or 100% Innodb, and I don't know, at least a third, maybe not even that high, maybe a quarter, end up having like 1 or 2 rogue tables out there that they weren't aware of that were MyISAM or Innodb. And so there's a couple ways that you can check in case you're curious if you are using MyISAM or Innodb or some mix. You obviously can issue the show create table, and that will show you the storage engine that that particular table will be in. You can also issue the show table status. So with the show table status, that's going to show you all the tables and what storage engine they are in. And if your version supports the information schema, you can always select off of the information schema for that. And if you're already all Innodb based, you probably don't really have to worry about a migration. But if you do find some tables that are accidentally MyISAM right now and you don't want it to be, you can always set the default storage engine for the system, and hopefully that will prevent any DBAs or developers from accidentally causing issues. Okay, so let's just assume though that you are going to migrate to Innodb from MyISAM. So you've checked your tables and you're all MyISAM and ready to do this migration. So what are some of the things that you want to watch out for? Okay, so first, I want to throw this out there. Some people treat this as not really a big deal to migrate. You want to treat this like any other upgrade that you do. So if you were planning to upgrade versions, what would be the process that you would go through to test that? And we typically recommend to do lots of testing. So definitely do regression testing, do benchmarking, do unit tests, check the latest READMEs and the storage engine specific information. When we go through and, Percona, the guys from, Percona go through and help you with an upgrade, these are things that we do. We want to test and make sure that we're not going to find some hidden gremlin in your system after the migration. And we'll go through some of the gremlins that we do see, but, regression testing is one of the key things for that. Benchmarking and regression testing kind of go hand in hand here. But, we typically, what we want to do is we want to capture a query stream for some amount of time and replay it versus MyISAM and versus Innodb. And we want to look for those, hey, did we get better? Did we get worse? Did we, see some weird issue that we hadn't seen before in another storage engine? And to do these types of things, MK Upgrade or MK Query Digest are going to be really valuable for you. So you might want to take a look at using those tools to either check for regressions or look for performance boosts. So having kind of thought a little bit about your upgrade process, and you planned your benchmarking, you planned your regression testing, you've put together some sort of test plan. You're probably interested in what sort of feature gotchas or the gremlins that I mentioned that sometimes occur in systems. So here's a few of them, and we'll talk about a few of these in a little bit more detail as we go on. But full text indexes, as I mentioned, this is a big feature in MyISAM for a lot of people. They don't exist in Innodb. Okay, so we'll talk a little bit more about that in a bit. The ability to compact or compress data. This is something that it's much easier to do in MyISAM, and depending on what version of Innodb you have, you might not even be able to do any sort of compression. The text on that's a little long. Multi-column auto-increment primary keys. That's something that Innodb doesn't support. If you're using GIS or spatial indexes, those are also things that Innodb doesn't support. A lot of data warehousing places end up using merge tables, or have with MyISAM, which made a really good poor man's solution for partitioning in previous years. There is no concept of merge tables in Innodb as well, so that's something else that you'll have to plan around and think about. Segmented key caches. This was a great performance trick in the olden days when you were running MyISAM. You could actually pin certain tables, or certain indexes into certain key caches. So you could kind of have a little bit more fine-grained control over what went where, and that's something that doesn't exist in Innodb as well. Dealing with deadlocks. There is no concept of a deadlock in MyISAM, so you don't have to worry about them. But when you migrate, all of a sudden deadlocks start appearing. How do you handle them? So you need to be able to kind of think through what will happen in our application when a deadlock occurs, and what do we want to have happen. And you might have to adjust some code around, or deal with that a little bit differently. And of course the locking, and we'll talk a little bit more about that. But going from table locking to row-level locking, it seems like this great thing, but sometimes it can have some really strange byproducts. So full text indexes. Mentioned that Innodb does not support full text indexes, so you should really check for full text indexes before you begin your migration process, and build a project around replacing them if you're going to. Okay, and this by far, in my opinion, and from what I've seen, is one of the biggest reasons for people to continue to use MyISAM. And there's nothing wrong with keeping a few tables around that are MyISAM specifically for full text, but just make sure that as you allocate memory and things, you leave enough allocated to MyISAM that it will actually work. But I would recommend, in everybody's system is different, but you look at some of the alternatives. So there's some great alternatives out there. For instance, Sphinx or Lucene. Those are two great full text search options. They have some good features. In fact, Sphinx has a MySQL storage engine that you can use. So, if you wanted to get some full text, out of the database and didn't want to use MyISAM anymore, you could potentially look at the Sphinx storage engine. However, if you're going to do full text searching, a lot of times if you do it outside the database, you're going to get a lot better scalability. So that's also something to keep in mind. Now, we mentioned another big feature for going to Innodb is the removal of table locks. So instead of doing a table lock, you're going to get a row level lock. And this is much more in line with other RDBMSs. So, this is, if you're familiar with Oracle or SQL Server, and you've done a lot of work with that, you're going to feel a lot more comfortable with Innodb than you do with MyISAM. But here's a caveat here. If you issue a lock table, Innodb will still gladly lock the table. And one of the things that we have seen with some applications is they expect a lock table condition to occur. So that's why it's important to do regression testing. So if you don't have a lock table, but you're still, expecting a lock table to occur when, a delete or an update or something happens to, kind of, how would I put that? Kind of push back some of the workload or stall the workload while, this delete occurs. You can run into problems when you switch to Innodb because that lock table won't exist. So you might actually have to put a lock table statement in your application in order to get around that type of a condition. Now there are exceptions to, row-based locking. Older versions of Innodb and a few newer versions, depending on what lock mode you have set, will perform low-level locks when you have auto-increment keys. Okay, so you know, that's something to keep in mind, that you could still see low-level table locks if you have an auto-increment key and you migrate to Innodb. Also, there are certain operations that will also cause table locks. For instance, select star from, load data, bulk inserts, etc. can still lock tables. Now, some of these are being fixed with row-based replication, but these are things that still do occur depending on your version. Okay, so you know, you want to make sure that, you know, if you are planning to have row-based level locking and you're expecting it, there are certain operations that could negate the use of the row-based locking. Okay, if you are doing like a, you know, insert into select star from, consider using like a select into out file instead, which doesn't cause the lock. Peter actually asked me to add this one. Be careful because he's run into this before. Sometimes an application is set up to have auto commit equals 0. And in MYISAM, that means absolutely nothing. So, you know, works great. You switch over to Innodb, auto commit equals 0, leaves transactions open for a really long time. So that's something that you want to really avoid if you can. Now, when you do this migration, one of the things you're probably going to have to ask yourself is, do you need more hardware? You see, Innodb stores its data completely differently than MyISAM, and as a result, the footprint on disk can be substantially larger. And not only does that mean that the footprint on disk is larger, it also means that the memory footprint can be larger as well. One of the benefits of Innodb is it will store both data and indexes in memory as opposed to MyISAM only storing indexes. Well, what that means is you're going to have the potential to consume a lot more memory as well. So, you know, do you need more hardware for this move? It's an interesting question that you'll probably want to evaluate and look at. But it leads to people asking the question, well, why the heck does Innodb take more space? I mean, you know, I hear that a lot. You know, and there's a lot of different reasons. First, Innodb stores its primary key as a clustered index, which means that on disk, all of the data is sorted based on that primary key order. Okay, so you know that sounds great if you know for optimization things if you're always accessing by the primary key, but it then uses that primary key, okay, as a lookup on every subsequent index. So every subsequent index will also include the primary key in it, and this can bloat systems substantially. I've seen you know, some systems have a really large primary key, and you know, the other indexes grow by 50–60% after migration just because this huge primary key has to be copied to all these other indexes. There's a 768-byte prefix for externally stored large columns that adds to space. Also, because we're doing row-level locking, we have to keep row versions, we have to keep transaction details, we have to have undo space. There's all kinds of other internal things that are occurring behind the scenes that require additional space in order to basically maintain that transactional system. Now, I wanted to throw this out there. You know, we talked a little bit about how MyISAM is not crash safe, and Innodb is crash safe, and it has durability. Your durability and your recoverability is only as good as your infrastructure. Okay, so I wanted to, you know, this is important. You know, we talked about hardware. If you still have, you know, like really bad disk and you get a corrupt disk, or, you know, your file system has corruption or something like that, you can still cause data loss in Innodb. Innodb just isn't the silver bullet that was, you know, going to prevent any data loss. So you still have to make sure that you know, build an infrastructure around that, you know, has, you know, redundancy. So, you know, you're using RAID, you know, you have a journaling file system, you know, you have battery backed cache, you do regular backups. You know, what the crash recovery in Innodb will allow is when if you went in and killed the MySQL process, or it crashed for some reason, when you start it up, it should come back and run through its crash recovery process and return you to, you know, the last good known state. It's not going to prevent you from losing data due to some other outage or some hardware issue. So just want to make that clear. Back to the indexing that I mentioned earlier. So, you know, we talked a little bit about, you know, the primary key in Innodb, you know, and how it's a clustered index and how it's stored in all the secondary index. You know, I want to reiterate, because this is a huge, huge, huge problem that we typically see during a migration is, you know, you've got these giant bar chart, columns that are used as a primary key in MyISAM, and it doesn't cause, you know, really any issue, but it can just be like this horrible performance drain and space drain when you move to Innodb. So, you know, you want to pay attention to that primary key size. And if you have a multi-key primary key or a really large, you know, text primary key, you might consider simply adding a auto increment key and make that the primary key, and then make the other, the former primary key like a unique key or something. This can, you know, substantially reduce the amount of space. And it can really save not only on disk space, but also in memory, how much space is wasted in memory just to store that extra primary key. Another thing I wanted to mention about the primary key while we're talking about it is, because it's stored in disk order, there are some optimizations that you can do, and you can see some pretty nice performance gains here. So if you have a table where you're always searching based on date and some other field, you might consider putting date in the primary key, you know, at the beginning. That way on disk, it's always sorted based on the date. We've seen some really, really good numbers coming back from that. So part of your migration obviously means a whole new set of configuration options, okay? You know, they don't share the same set of configuration parameters, so you have to learn and understand a whole new list of parameters. You know, we mentioned the key buffer. The closest thing to the key buffer is the Innodb buffer pool size. And this is probably the most critical of all of the settings in Innodb. This is going to dictate how much memory is allocated to Innodb and how much space in memory can be stored for the data pages and the index pages. So the bigger this is, typically the better, but that's not always the case. So there's some edge cases. Again, I'm not going to go into a terrible amount of detail on all the parameters. There's a webinar tomorrow on Xtradb. You know, we'll talk a little bit more about, you know, Xtradb and like the some of the Innodb parameters and Xtradb and some of the fixes and things. And then there's training classes and things that can go into a great amount of detail. But here, you know, the key thing is when you do the migration, Innodb buffer pool size should be sized appropriately. You know, this is going to give you probably the most bang for your buck. And you're going to want to reduce the key buffer pool size to something a lot less if you're going to be 100% Innodb. I have some more slides on configuration parameters, and I'll mention those in a second. But again, the difference between the key buffer and Innodb buffer pool might seem, you know, like minimal to you. You know, oh yeah, one stores indexes, one stores indexes and data. But it does have a fairly substantial impact, because there's going to be less indexes in memory, which means that if you're relying on index-only access and you know, a few things, you could see some craziness where the number of indexes that fit in MyISAM might not fit in a similarly sized Innodb buffer pool. So it's just something to keep in mind that, you know, hey, you know, there's also data and there's also other transactions and there's also things like the insert buffer and other things that are stored in the Innodb buffer pool that are going to consume more memory than MyISAM needed to store the same indexes. Also, don't over-allocate memory when you go to these. You want to still make sure that you leave some memory for the OS and things. But other key parameters. You know, here's, you know, if I was going to give the top 5, obviously the Innodb buffer pool size would be number 1. But other key parameters that, you know, you should really look at are the Innodb flush log at TRX commit, the Innodb flush method, the log file size, and the Innodb thread concurrency. The Innodb flush log at TRX commit will actually dictate if at every commit you're going to actually flush your data to disk or not. The Innodb flush method, we typically set this to O-direct. What that means is, by default, Innodb, because it has to be durable, has to write everything to disk. It makes sure that it ends up making it to disk, but without this set, it will write it to disk, into the file system cache, and into the buffer pool. So you've got it like 3 different places, right? By setting this to O-direct, it says, well, you know what, skip the file system cache. I don't need to write to the file system cache. There's no reason to write it there because I've already got it in memory and I've already got it on disk. So, you know, let's just bypass that. The Innodb log file size, the larger you set this, the longer you can stave off certain flush operations or certain, you know, like background write operations. However, while you might improve transactional throughput, you're going to pay the price on startup and shutdown because these logs need to be flushed. And also during a crash recovery, having this set really large can really impact the length of time that it takes to do that crash recovery. And the last one is the Innodb thread concurrency setting. The Innodb thread concurrency setting is you know, one of these settings that will dictate how many threads can actually be active in Innodb at any one time. And this doesn't mean that if you have 50 things running that, you know, everything's going to wait. It just means that at any one given second, that's how many threads can be active in Innodb. So, you know, setting this to something reasonable can make a huge difference. I've seen a lot of cases where, you know, you set this to, you know, 4, and you know, you see this giant queue, you know, like, you know, grow, and then you end up setting it to 16, and you know, now everything just flows through the system, and you know, you've got this huge performance benefit. Also realize though, the Innodb thread concurrency, depending on the version, could also uncover a lot of other internal mutex and semaphore type contention, because more threads are running at once. You have an increased likelihood to hit things that haven't been fixed, especially in older versions that don't have like Percona patches or the Innodb plugin running. So, you know, setting that higher means more things run at once, which means a greater chance of internal contention. Now, you know, I wanted to call this one out especially, the Innodb flush log at TRX commit. This can have a huge benefit in IO-bound systems because to be completely ACID compliant, every commit should be flushed to disk. This is defaulted to 1. However, setting this to 2 means that at every commit we're going to write to the file system cache, but every second we're going to go ahead and we're going to flush that to disk. So we basically batch those writes to disk, and the batched writes to disk perform much faster than the individual writes at every commit. So this can have a huge performance impact. But realize that in case of a crash, this means you could potentially lose up to a second's worth of data. And if you set that to 0, that actually means only write to the file system cache and to the disk every second, as opposed to writing to the file system cache at every commit. With Innodb, the Innodb plugin and Xtradb and the Percona patches, there are actually several new parameters that have been introduced. So, you know, these are a few that, you know, you might take note of. There's actually Innodb adaptive flushing, and there's also an Innodb adaptive checkpointing. And these will actually, when flush or checkpoint processes occur, these actually help smooth out like the valleys that occur when those processes tend to happen. You know, they're very intensive processes, and the adaptive flushing is actually going to help, you know, you maintain and overcome those dips in performance. So it'll cost you a little bit in terms of transactional throughput, you know, over time, but you're not going to see these, you know, this sawtooth type pattern. Innodb I/O capacity. This is, you know, I mentioned that Innodb originally had, you know, hard-coded values that said, hey, we're not going to do more than 100 IOs a second. This actually changes that, so you can actually have your background threads do more than 100 IOs a second. So you can actually set it to whatever your disk is. So that's something that's a huge, parameter in the plugin in Xtradb. Innodb read ahead, that can be disabled now. So for a lot of applications, I've found that reading ahead actually doesn't help. And so you can actually disable it if your application doesn't need to do read aheads internally. And then you can also configure now the number of read IO threads and write IO threads. And these are the background threads, so when a flush process or something has to happen behind the scenes that either has to read or write, by default, it used to be that you got one IO thread for read and one IO thread for write. So you were really single-threaded in a lot of these processes. And this was a huge bottleneck. So now they've introduced the concept of configurable number of read and write threads. So you can actually parallelize that workload. All right, so you've kind of walked through and you've figured out some of the gotchas and you've set some of the parameters up and you've gone through your testing plan. Now you're probably going to ask, hey, how am I going to migrate? Okay, what's actually going to be the steps, or like the actual, what do I do to get it from MyISAM to Innodb? And this depends heavily on your system. Okay, a lot of cases, it could be a simple alter table XXX engine equal Innodb. So you change the storage engine, it rebuilds the table, becomes Innodb. Sometimes a simple dump and reload is works. But every situation is unique. So a lot of times what we need to do is look at your situation. This is specifically geared towards larger systems because size can make a huge difference. The larger the tables, the longer like an alter table will take. So a lot of times we need to plan around like a downtime window or figure out tricks in order to make the migration happen faster than just a simple alter table can do. So a lot of times we'll end up using replication. So and this is something that you can do in your application as well. So maybe what you do is you create a master slave, or maybe you already have one. You make sure that the data is in sync, so you can do that with the MK table checksum tool, part of MATKit if you want. And then you can alter the tables on the slave, and if they take a week to run on some really massive table, if you're not using the slave, well, it takes a week. Then at the end you let it catch up. And then you can run your MK table checksum again and make sure that the data is in sync. And after you've verified that everything is good, you can then promote that slave to become a master. And then you have complete migration with minimal downtime, which works out really well for a lot of clients. So it might be something you consider. But one of the other benefits of this approach is you can actually run a lot of your tests against that slave after it's been migrated. So if you wanted to replay your query stream, let's say you wanted to throw all your selects against it and do some more regression testing, you can get a full-size database copy and really verify that you're not seeing any sort of regressions. So let's talk a little bit about some of the maintenance-y type things that are going to occur or that have occurred. You've kind of done your migration here. You've set up your system. You've got things running. So now, you're probably worried about how am I going to maintain this new system or what's different. One of the things that I mentioned is the stats gathering, okay? You used to be able to, in MyISAM, run the analyze command and analyze would update the statistics and, change query plans and whatnot. Well, now stats are gathered behind the scenes. So you don't actually have to run that. So some people consider that, hey, great, I don't have to worry about it. I don't have to worry about actually, running this when I change things. But this can actually cause lots of issues with larger data sets. So, while you don't have to run the stats gathering, with larger data sets, what we see is a lot of times this Innodb will grab the data and run the stats, and you'll get this great explain plan, and the performance of based on those statistics is just spectacular. It runs in, let's say, a second. And then randomly at some point in time, it runs stats, and all of a sudden everything changes because it looks at those stats and chooses a completely different plan. And you go from like 1 second to 10 seconds. And it's just this random, strange, like movement of, the optimizer that, just boggles some people's minds. So there's actually a couple of parameters that were added into Xtradb, and I don't, I think these are only Xtradb only. Well, the Innodb stats sample pages is, but the Innodb stats auto update is. So you can actually set the auto update of the stats to off in Xtradb. So you can say, you know what, don't update the statistics. Okay, just do it the first time and then leave it alone unless I specifically run an analyze to update it. So you can actually turn that off, which is really helpful in super large data sets. The other thing that Innodb does is Innodb only bases its statistics off of 8 pages. So a really small footprint. It's actually 128K of data, I believe. A really, really, really small footprint of data. So, you can actually set the sample size of stats. So you can say, oh, you know what, I want to do this over 100 pages or, 200 pages or something. But the more pages that you tell Innodb to use to analyze, the longer that actually takes to do the analyze. So that's something to keep in mind. There's also a new parameter in Xtradb where you can actually store the statistics in a table and it can survive reboot, which I haven't played with, but looks really beneficial. And Morgan might actually go over that tomorrow with his Xtradb webinar. So one of the other things that you're going to have to, or that you're probably wondering about, is your backups. A lot of people who have full MyISAM systems end up doing MySQL dumps or doing cold backups. They might, do the dump off a slave. They might do it off the master. They might do the cold backup off of a slave. But typically those are two very popular ways of doing it. Of course, MySQL dump locks. Okay, so that's something that you might be hoping to get rid of that locking. So if you're going to switch, or if you're going to continue to use MySQL dump, you'll probably want to look at using the single transaction parameter in the MySQL dump, which is actually going to give you a consistent snapshot without causing a full lock of the system, with Innodb. But there are actually other options that you can do, non-blocking options with Innodb that you couldn't do with MyISAM. For instance, you can actually do non-blocking hot backups with SAM snapshots, LVM snapshots, extra backup. With the SAM snapshots and the LVM snapshots, you're basically taking the snapshot of disk and then it comes back up just like a crash recovery. So it'll roll through the logs, it'll bring it up to the point where you need it, and these are really great ways of doing a backup, and generally much quicker than using MySQL dump or a cold backup. But realize that these all do cause resource contention. Okay, so you're going to see an increased amount of I/O on the system, so you could still see some weirdness if you're going to run this on like your production system or your master. Now, I mentioned this earlier with the hardware discussion. One of the biggest benefits of recoverability or of Innodb is the ability to be more ASIC compliant or more crash safe. Realize that this does not mean that your data will never become corrupt. Okay, Innodb is not going to protect you from losing data if you've set the Innodb flush log at TRX commit, let's say, to 2 or 0. You could still lose a second there. If you have a replication issue, your replica is still going to be off. If you've got you hit a certain bug or error in MySQL, you could still lose data. Okay, so you want to make sure that the expectation set, especially to your management, that yeah, this isn't a silver bullet that's going to prevent us from ever losing data. Okay, but it's much better than it is in MyISAM. Okay, corruption in MyISAM is bad because the data loss can have no rhyme or reason or pattern to it. Okay, you could lose data out of these 10 tables and not out of these other 20 tables, and the next time you could have some different subset of data being lost. So it's much better in terms of recovery in Innodb, but it's not bulletproof or fail-safe. Now, in terms of performance, most, of the people that I work with, not all, tend to get better performance out of Innodb. And that's not necessarily out of the box. A lot of times it requires tweaking and, configuring the system and making sure that things are optimized for your specific workload. But in the end, most people typically get better performance. A lot of times, there are certain operations that don't, okay? For instance, select count star, okay? If you do that on a full table in Innodb, it is way, 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 way slow, okay? If you do it in MyISAM, it's relatively fast, and it's just the way that they store that type of data. Now, this doesn't mean that if you have a select count with a where clause that where clause is going to be exceptionally slow in Innodb. It could be really fast. It might even be faster than MyISAM. It just means that if you're going to do it over the full, table, that's going to potentially cause issues. Also, insert performance. Some people say, they get faster insert performance out of MyISAM. Some people say, that's bunk. It depends on the application, but because there's overhead in how Innodb stores data and its transactions, certain applications could see a performance benefit in insert workloads because there isn't as much going on in as in Innodb. But that's not always the case. A lot of, it depends. So just realize that it depends. I mentioned primary keys. That's a huge performance, either improvement or detractor in Innodb. So, keep that in mind. And also realize that Innodb is going to require more tuning than MyISAM in order to get right. When you do this conversion, if you do this migration, you have a really large potential to change your bottleneck, okay? And what I mean by that is your bottleneck could end up, being, let's say, a locking issue, okay? And if you clear that locking issue, all of a sudden you might throw more threads that are active at one time at the CPU, and all of a sudden your CPU might get pegged. So, you want to make sure that you realize going into this and you set the expectation for anybody who's also looking at the system that this type of change is going to completely change how the system looks and behaves. Okay, you're going to free one bottleneck and could expose another. It could be disk, it could be, CPU, it could be, memory, all these types of things. You're moving from one bottleneck to another, and that's not necessarily a bad thing. Okay, I've run into a couple times where, I've worked with clients who, freak out because they're looking at the CPU, and after an Innodb migration, the CPU goes from, 40% to, like 90%. And they just go, oh my God, what did you do? This is horrible. It takes up 50% more CPU than anything else, or than MyISAM did. And it's not that it took 50% more CPU, it's just that we freed up the bottleneck, and now all of a sudden we were getting like 3 times the transactional throughput, but 3 times transactional throughput basically, brought the CPU to almost being pegged. Well, you're getting more throughput, so you got to make sure that when you start looking at your system and your stats, that you're looking at the right metrics and you're not trying to make correlations between the MyISAM system and how it was performing and the Innodb system and how it was performing based on numbers that can be skewed by things like the amount of throughput going through the system. And also realize that a lot of applications might still be optimized for MyISAM, whether it's a blog or whether it's some third-party software. They might be optimized for MyISAM. So check with them and check their READMEs to see if they have any specific issues with moving to Innodb. Here's my kind of pro tip for the day. Whenever you hear people talk about MyISAM or Innodb and what they're great at, for a lot of applications they could be right, but a lot of times it depends. So don't believe everything that you hear. Like for instance, MyISAM is faster on reads and inserts. This is something that has been perpetuated for ages, and in certain workloads it can be. What are other workloads? InnodB is faster. So, you know, it depends on your workload, and just because, you know, your friend gets some giant performance boost doesn't mean that you're going to get a giant performance boost in your application. So, you know, we've kind of talked a little bit about, you know, the MyISAM, you know, versus InnodB, but what if you actually do need a feature like full text, or you do need a feature like, you know, just indexes or things like that? There's nothing wrong with mixing those, okay? You know, go ahead and, you know, you can have them, you know, both in the same, you know, system. You know, what's probably better is considering, you know, running InnodB on the master for everything, and then let's say have a slave that's specific to MyISAM that has those additional features enabled, and then, you know, redirect the traffic for the queries and things that need that to the slave. But when you mix InnodB and MyISAM, if you join the two tables, you're going to get the lowest common set of features. So, you know, if you do like an update and you join InnodB and MyISAM, it's going to table lock. You know, there's not going to be any transactional support. You know, so whatever the lowest set of features is between the two, you're going to end up getting if you join them together. Also, because each of the storage engines uses separate memory pools and have separate resources, if you're going to split these, you have to be careful that you're not hurting one of the storage engines over the other, because you're going to effectively have to split your resources. So you're going to have to watch that very closely. How much memory do you really need for MyISAM versus InnodB? So, you know, tip of the iceberg here, you know, there's a ton more on InnodB specifically, you know, that you probably want to learn before in migration. So Percona does offer training. You know, we do offer one-day and multi-day training classes. So, you know, you might consider, you know, joining us for one of those. You know, there's some really good material in there, and you know, they do a bang-up job over in the training department. Also, if you're planning to do a migration, maybe you want to, you know, have Percona help you out. You know, we do offer, you know, a full range of support and consulting services. You might only want someone to come in and just kind of give you a plan and you execute the plan, or you might want someone to actually do the whole migration for you. We can help you with both of those. So, you know, you might consider calling us if you have a problem, or if you want some just some advice on how to do the migration. That's all I got for you right now. Let's see if we've got any questions staged up. All right, so will I be sharing the slides after the presentation? I believe so. I think that, you know, I can provide those for Nikki, and she can go ahead and she can put those out on the web. Let's see, let me go back, hold on. Trying to get to these in order. Let's see. What's the max number of CPU cores that the Percona server is optimized for? I talked to Vadim about this, who is our CTO, and he said that they have seen really good performance up to about 24 cores now with the latest version. And that was about a month ago, so that might have even changed by now. But about 24 cores is the limit of where we've tested and seen, you know, performance without a regression. Is MySQL dump -- single transaction a hot backup? Yeah, it's not going to lock the tables. It's still going to cause resource contention. So, you know, using, you know, the MySQL dump on the InnodB tables without with the single transaction is basically going to give you a consistent snapshot across all those tables without doing the full table lock. So I guess you could consider that a hot backup. Let's see. What monitoring and profiling tools would we recommend for InnodB? Well, that's a good question. There's quite a few options out there. MK Query Digest is great to analyze the slow query log. If you can't get the data that you need out of the slow query log, you could use TCB dump and redirect it through there. We typically will end up deploying like Cacti and the MySQL templates to do sort of, historical monitoring of the system to make sure that we get, good numbers, and so we can go back and look at, hey, what happened last night at 10 o'clock, or what happened last night at midnight, or something like that. So those work really well. Let's see, is there any other things that, there's several tools out there that you could also look at depending on your application architecture. And a lot of them aren't Innodb specific. So, I guess it depends on the infrastructure, or, like your development tools and things, because there's tools out there for Java, there's tools out there for Ruby, and a lot of them also give you tools that go all the way down to, like the MySQL level as well. Yes, okay, the question is, did I understand you correct? I can set up a slave, sync it with the master, then alter the tables on MyISAM to Innodb. From MyISAM to Innodb on the slave, and it will stay in sync. Yes, it will. Yep, it will. It will stay in sync. You could see some strangeness if you have any lock tables, but that's a method that we've used many times. So actually, using a slave works really well, and you can have the slave and the master have two separate storage engines. Okay, question was from Jack. You mentioned that large tables can sometimes cause problems or require different approaches. What would we consider a large table? Well, that's a good question. It varies from system to system, depending on hardware and things. But typically, where I've started to see problems is when you get, I don't know, above, let's just say, arbitrary numbers, 50 gigs, 100 gigs type of thing, 10 million records. It varies depending on like the size of the records and the number of records, but we're talking some substantially high numbers. All right. So let's see. Another question was, if you only migrate some of your tables to Innodb, what are some of the issues if you have those split? Obviously, part of the problem is you're not going to be able to do like a hot backup, okay? You can do a hot backup of the Innodb tables, but the MyISAM tables still have to be locked fully. In that case, you're going to potentially get inconsistencies between the tables. So if you're relying on, let's say, an ID in a MyISAM table to have a matching or corresponding child in an Innodb table, if those are backed up separately, one hot, one cold, those are obviously going to get out of sync. So realistically, you would need to lock all of the tables, including the Innodb tables, in order to get a fully consistent backup, which is probably what you want. Some people don't need that, but that's just one of those things that you end up going to the worst of the features. What would I recommend as a substitute or enhancement for the Innodb portion of MySQL report? Don't know off the top of my head. I'd have to look or think about that. What is the preferred way of gathering queries and replaying them against a new version of the database? Should I use the binary log, or is it better to use a TCP dump? That's a great question. Binary log is only going to have your insert, updates, and deletes. It's not actually going to have your select statements in it. So using a binary log, unless you just want to replay the transaction or the inserts, updates, deletes, isn't going to be beneficial. However, a TCP dump is going to capture everything. So I prefer a TCP dump or using the slow log. You can set the slow log, depending on your version, to 0 and capture everything. That's another great way to do it. But after I get the TCP dump using MK Query Digest, MK Table or MK Upgrade, or MK Log Player, I've used all those in the past to try and get some metrics between the two servers. So those are some of the tools that I've used and I find pretty well. Would it be advisable to migrate parts of the database at one moment as opposed to migrating everything in one go? That's a good question. It depends on your particular application. Obviously, if your application is broken up in such a way that certain tables only impact certain, applications, or like have certain functionality, that might be easier to do, kind of like a staged migration, where you do, this portion of the app tonight and this portion of the app the next night, things like that. The only negative about doing, like a migration like that is you're going to risk potentially inconsistencies. If you're trying to do anything that has balance across tables, so if you insert a record into table A and it's Innodb, and you insert another record into table B, which is MYISAM, if you're expecting like a transaction to keep those consistent, obviously that's not going to work because MyISAM doesn't have transactions. So you could potentially get some data weirdness there. If the system crashes, Innodb could have a full copy of the data, but MyISAM might be missing some of the data. So there are issues there, as well as you're going to have to then slowly bump up your resources to Innodb as you do the migration. So you would start off, let's say, having, all of your memory allocated to MyISAM, then you'd have to take some of it away and move it to Innodb and then kind of trickle it over. So there might be some weirdness. So I don't know if I'd want to do that unless I knew the application well enough. Would be setting up a slave with the Innodb engine and simply replaying the production queries be a sensible way of regression testing? Not entirely. It's a good first step. Replaying the queries can definitely give you a sense of hey, that this is these particular queries haven't seen a regression in overall response time, but you're not going to get an idea for things like concurrency issues, or if you have application-specific logic, you might not know how your application responds. So the replaying of the logs is a great first step, but I don't think it replaces the need to do full end-to-end type testing, where you would then have like a user hit some of the pages and see what happens, maybe run some of your jobs against Innodb, things like that. So that way you can get more of a measured regression test, where you can say like, okay, the queries are fine, but when we run our normal nightly load, that causes problems with queries or something like that. So you'll be able to figure that out before you get into production, which is always a good thing. Replication in replication master with Innodb and slave with MyISAM setup is useful in what scenarios? In that scenario, it's useful if you want to add full text indexes or spatial indexes. Those could be really beneficial. The other thing that I find it beneficial in when you want to run a MyISAM slave and an Innodb master is if you want to use the slave for more of an archive. So I've done that in the past, where the storage on the slave is you want to keep that a little more compact or something. But typically it's for full text or spatial indexes. Is there a significant difference in the way that deletes are handled between MyISAM and Innodb? Indeed there is, because Innodb is transactional. You've actually got to keep old versions of that deleted row around. So you have the whole transactional construct around that, which is going to cause it to be completely different than the way MyISAM handles it. What are the difference between issues when using LVM snapshots for backups of MyISAM tables versus Innodb tables? When you do an LVM snapshot of a MyISAM table, you obviously have to lock the table before you do it. If you don't lock the table or shut down the system, you're going to probably bring up a corrupt backup. Don't want to do that. That would be bad. So let's see. Oh, more from Jack Squires asking about the deletes. Sometimes cause performance problems as it leaves holes in the data stored and reduce disk I/O efficiency. Okay. So this is one of the maintenance operations. You probably have run like optimized table and things, or altered your tables for MyISAM to clear up some of that wasted space. Because Innodb actually stores its data on disk in primary key order, it's actually much better about cleaning up that space. There's actually a purge process that comes along behind the scenes to clean that up. So there are some issues when you do deletes that you could still see some purging or purge lag, but there are some parameters to help tune and optimize that if you're seeing problems with lots of deletes. But it's not nearly as bad as it is in MyISAM. What about difference in performance of Innodb versus MyISAM, where the select count star from table where condition is used? Depends on the where condition and how it's indexed. So, your select count star could be, as fast as MyISAM if it's properly indexed, and you're looking for a small subset of data. It might even be faster. It's really typically a performance issue with the select count star when it's a select count star over the full table. Would I use a Innodb as a storage engine for sessions? That's an interesting question. It depends on like the sessions. Typically with sessions, you're seeing heavy transactional read writes. So with the heavy transactional or heavy read writes, MyISAM or the memory storage engine typically doesn't work well. Innodb can work well. It just depends on the load. A lot of times what we'll end up seeing is we'll end up recommending people go to like a memcached or something for their sessions if they can. Depending on the system, like some really large gaming systems, we've actually used like NDB cluster for sessions. But Innodb can keep up with a lot of sessions, and I have seen it run as like a session store successfully on many clients. It really depends on the application though, and there are other options that might be better depending on that. And are there issues with altering an Innodb table or migrating a MyISAM table to Innodb that it says that has more than, say, 200 million records? So many records that the primary key is many times the size of the memory. MyISAM has an issue where it will sort row by row rather than doing a file sort. To order the primary keys as it inserts the records and will check for duplicates. This is one of the things that if we're going to do a migration on something that's 200 million records, we'd probably want to look at potentially the way we're going to do it. We get a better throughput by inserting that data into an Innodb table in primary key order. So we probably have to think and plan around how to effectively do that. Not sure off the top of my head. I probably have to dig into it a little deeper. Yeah, an alter table could take a really long time. It's going to take a really long time with the with 200 million records. I guess it depends a little bit on the size of each of the records, but yeah, I mean, there's just no way of getting around that. It's going to take a long time. And does the performance of an altered table add? Altered table, and you're going to add anything, or altered table in the older versions of Innodb. So when you go to add a column, you go to add an index, it actually rebuilds the entire table. So it's going to be nasty slow. So you want to make sure that you avoid that if possible. All right, well, I think Nikki wants us to wrap it up here. So thanks, everybody. Appreciate everyone coming in. Look forward to talking to you in the future, and we will see you all tomorrow for the next webinar.